Okay, quick question before we start. Why do black holes make no sense? Like, actually think about it for a second. Something so dense that light itself, the fastest thing in the entire universe, cannot escape it. Not slow down, not struggle, cannot escape. That is such a strange, almost impossible sounding fact that most people just accept it and move on without ever really sitting with how bizarre it is. Hi, I'm Potato, and today we're going to actually sit with it. We're going to break down black holes piece by piece using something you already understand perfectly well, and then, at the very end, I'm going to tell you something slightly unsettling about your own body. So stick around, because this one gets personal. Let's start with the basic idea of gravity, because everything about black holes is really just gravity taken to an extreme. You already know gravity as the thing that pulls you down toward the floor and keeps your coffee mug from floating off your desk. But here's a better way to picture it, one astronomers actually use. Imagine space itself as a big stretchy trampoline sheet. Now put a bowling ball in the middle of that trampoline. The fabric dips down around it, curving inward. That curve is gravity. Anything rolling nearby on the trampoline doesn't get pulled by some invisible force reaching out and grabbing it. Instead, it just follows the curve in the fabric, rolling downhill toward the bowling ball because that's simply the shape of the space around it. Now here's where things get interesting. What happens if you take that same amount of mass, that same bowling ball, and you squeeze it down smaller and smaller and smaller without losing any of its weight? The dip in the trampoline gets steeper and steeper. A bowling ball the size of a basketball makes a gentle dip. Squeeze that exact same mass down to the size of a marble, and now the trampoline doesn't just dip, it plunges. The sides get so steep they're almost vertical. Keep squeezing. Keep shrinking that same mass down smaller and smaller, past the size of a pinhead, down towards something almost unimaginably tiny, and eventually the fabric doesn't just plunge steeply anymore. It tears completely through. The dip becomes a bottomless well with walls so steep that nothing, not a marble, not a bowling ball, not even light itself, has enough speed to climb back out. That bottomless well is what we call a black hole, and the edge of that well, the last point where escape is technically still possible if you're moving fast enough, is called the event horizon. This is genuinely the most important idea to understand about black holes, so let's slow down on it. A black hole isn't some special exotic type of matter that's fundamentally different from everything else in the universe. It's just regular matter, the same stuff you're made of, squeezed into an incredibly small space. Our sun, for example, would need to be compressed down to roughly the size of a small city to become a black hole. Earth would need to shrink down to about the size of a marble, all of Earth's mass, all 6 sextillion tons of it, packed into something you could hold in your hand. Nobody is doing this intentionally, by the way. It happens naturally when massive stars run out of fuel and collapse under their own weight, with nothing left to hold that steep gravitational dip open anymore. Now let's talk about what actually happens if you got close to one, because this is where the bathtub drain comes in. Picture a bathtub slowly draining. Near the edges of the tub, the water barely moves. But as you get closer to the drain itself, the water speeds up dramatically, swirling faster and faster the closer it gets to that central point. If you dropped a little toy boat into that water far from the drain, it would drift along calmly. Drop it close to the drain, though, and the water pulls at different parts of that boat with wildly different strengths, the front getting yanked toward the drain much harder than the back, until the boat twists, stretches, and eventually gets torn apart by the mismatched forces acting on its different ends. That's essentially what happens to anything falling into a black hole, and astronomers gave it a wonderfully dramatic name: spaghettification. If you fell in feet first, the gravity pulling on your feet, which are closer to the black hole, would be dramatically stronger than the gravity pulling on your head, which is slightly farther away. That difference in pull, called a tidal force, would stretch your entire body longer and longer, thinner and thinner, until you resembled, well, a piece of spaghetti. It's not a metaphor. It's a genuinely accurate description of the physics. So here's the twist, and this is the part where things get personal. That same tidal force, the same basic physics behind spaghettification, is happening to your body right now. Not from a black hole. From Earth. Let that sink in for a second. Earth's gravity pulls harder on the parts of your body that are closer to the ground than it does on the parts farther away. Right now, gravity is tugging on your feet slightly more strongly than it's tugging on your head, because your feet are closer to the center of the Earth. The difference is unbelievably tiny, so small you will never, ever feel it, but it is not zero. Technically speaking, right now, this very second, Earth is very, very slightly stretching you. You have a microscopic, utterly imperceptible spaghettification happening to your body at all times, just at a scale so unbelievably weak compared to a black hole that it might as well not exist for any practical purpose. This is actually a fantastic way to understand why black holes are so extreme. It's not that they invented some brand new force that regular gravity doesn't have. It's that they take an effect Earth already has on you, the same tidal stretching, and turn the dial up by an almost incomprehensible amount. Near a black hole's event horizon, especially a smaller one, that tiny stretching effect that you can't feel from Earth becomes strong enough to rip apart steel beams, let alone a human body. The difference between you standing on the ground right now and you falling into a black hole is really just a difference of degree, not a difference of kind. Same physics, wildly different intensity. Here's another mind-bending piece of this puzzle. If someone could safely watch you fall toward a black hole from a distance, without falling in themselves, they would never actually see you cross that event horizon. From their perspective, time near the black hole appears to slow down more and more the closer you get to the edge, stretching out infinitely, so to an outside observer, you'd appear to freeze right at the boundary, fading dimmer and dimmer, forever approaching but never quite arriving. Meanwhile, from your own perspective, assuming the tidal forces hadn't already spaghettified you, you'd cross that same boundary in a completely normal, unremarkable instant, feeling absolutely nothing unusual at the exact moment you pass the point of no return. Two completely different experiences of the exact same event, both equally real, depending entirely on where you're standing when you watch it happen. So the next time someone tells you black holes make no sense, you can tell them they actually make perfect sense. They're just gravity dialed all the way up, doing to matter what Earth's gravity is already quietly, imperceptibly doing to you every single second of your life. You're not separate from this cosmic phenomenon happening light years away. You're running a microscopic version of the exact same physics right now, standing wherever you happen to be standing, being very, very slightly stretched by the planet beneath your feet. Kind of wild that the same math describing one of the most violent, extreme objects in the entire universe also describes the completely unnoticeable, everyday experience of just existing on a planet, right? The universe really does love reusing its best ideas at every possible scale, from the impossibly tiny to the impossibly massive. Thanks for hanging out with me today. If your brain enjoyed stretching itself around this one, pun fully intended, stick around, because the universe has plenty more strange surprises like this hiding in perfectly ordinary, everyday things. I'll see you in the next video.